Hello and welcome to another video with Dr. G. So today we're talking about Batman's crime solving efficiency. Got this nice picture of Batman looking into his microscope at the Batcave lab. And so, does Batman solve crimes faster than the average detective in Gotham? Well, we want to compare how long it takes Batman to solve crimes to the established timeline of GCPD. So they collected data for last year for the different departments, and here's what we have. So the GCPD mean time, the population mean mu is 72 hours, and the GCPD standard deviation, the population standard deviation sigma, is 10 hours. So I have a simple random sample of data for Batman's time to solve these 10 recent cases that we're going to do the descriptive statistics on. And so we have the population standard deviation, so we need to do a z-test. Since the sample size is less than 30, we need the population to be reasonably normal. Given that the population of time to solve crimes is normal, we can continue with the test. So it's very important that we check these assumptions as we go forward. So we're going to head over to Jamovi now to handle this difficult case. See what I did there? Okay, so here we are in Jamovi, and I actually have the time to solve over here. So I'm going to come into data, and I'm just going to show you the setup. I called the data variable time to solve, and I gave it a little description, number of hours needed to solve a case. I made sure that the measurement type was continuous so that we could use it. Okay, so there's that. I went ahead and took the 10 cases at random, right? A random sample of the 10 cases and put it here. Now, what we want to do is we want to take a look at our data to begin with, right? So I'm going to go to analysis and I'm going to go to exploration and I just need the descriptives, okay? So results, descriptives, you can see the number of values and the mean are here, and those are the two things that I need. So there aren't any missing. I don't need the median. I don't need the standard deviation, minimum or maximum. I could do all of those things, and we are going to come back and maybe look at the confidence interval. But right now, what I need to do is take the time to solve and throw it over into the variable. And now you'll see that there are 10 observations and that the mean is 34.80. So that makes us really happy. Okay, so now what do I need to do? Well, if we have the population mean and the population standard deviation, normally what we would want to do is a one sample z-test. Now, this is not a module that is pre-installed on Jamovi. So what we want to do is we want to go over to Jamovi's and to the Jamovi library, and available here, let's see, let me delete, right? So you've got all of these here. All I did was actually typed in Z, and the ztestviz conducts a one sample t-test, comes up. And that's actually what I want, a z-test that visualizes our one sample z-test. And again, we're doing a one sample z-test because we know what the population standard deviation is. We're going to see that in a minute. Now, I've already installed it. It is under this miscellaneous package, and I'm going to go ahead and click on one sample Z. Now, I can't scroll this over. Now, you'll notice it asks for the sample mean, right? Well, the sample mean is the 34.80. So let's go ahead and put our 34.80 in. The population mean from GCPD is the 72 hours. You'll remember that the sigma, the population standard deviation, was 10. So the mean and the population mean, mu, and the standard deviation, population, sigma, are needed, and because we have them, we're doing a z-test. Now my sample size is 10, so we're going to change this to 10. And I don't want to know if Batman is different. I want to know if he is faster, if he is less than 72 hours. So when I go over here, I wonder if I can just double click. No. Sometimes you can double click and make that go off to the side, but we can't. Let me do data, and then I can scroll this over. Perfect. All right, so now you can see our observed z-score is, so this would be our test statistic, is negative 11.76. So this is almost 12 standard deviations below, which is crazy. Our standard error is 3.16. So obviously, if you took a mean of 10 and you divided it by the square root of 10, you would get 3.16. The p-value is less than 10, 100, 1,000, so less than one sample in 1,000. All right. Now, what's really cool about this one is it actually gives you the population mean and standard deviation. So this is our population curve right here, and then there's our sample mean on the population curve. But then here's our sampling distribution. Notice it's centered, which it should be, but it has a smaller variability. Its standard error is 3.16. And so this would be the critical region. For those of you who are doing the critical region test, that would be it. So you can see our sample mean is way, way over here. Again, it is almost 12 standard deviations away. So we would reject the null hypothesis. Now, something that's really cool that you may not have noticed, this is 3 decimal places, and I know that some systems ask for 4 decimal places. What you can do is you can go over to the snowman. The 3-dot stacked is considered a snowman. And so when I click on it, the p-value format, you can change that to 4 decimal places if you need that number of values, right? So we're going to go ahead and leave that as tens, hundreds, thousands, 10,000. Now, if you need an exact value, you could actually do 3 significant figures, but notice that's a really, 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 really small p-value. So I'm just going to go back to 4 decimal places and leave it like that. All right, so now we're going to go back to our Word document and look at our interpretation. Okay, so now you can absolutely see that we reject the null hypothesis. So what is our interpretation? This is a very common way of writing this up. At the 5% level of significance, we reject that the mean time for Batman to solve a case is 72 hours. We have evidence that the mean time for Batman to solve a case is less than 72 hours. Our p-value is less than 0.0001. And so what does this mean? The practical interpretation means that Batman solves cases on average in less time than the GCPD. And that makes us happy.